here's on a booster oil system using HB sensors. If you walked in and that's all you saw, could you fix it? Could you walk through the circuit? Where would you start? A lot of times that's the question. Where would you start? Well, if I had this compressor off on oil and I knew this was my troubleshooting circuit because I understand the circuit, well, the first thing I'm going to start now, I'm going to go through the sequence of operation, normal, then we're going to back up and fix it. All right. So the first thing that's going to happen in the circuit is, for those of you who have worked on these, this is that HB sensor that you use in ammonia all over the place. They use these in Europe. Trevor and I were both just in Chilventa, and I saw them all over the place, this HB sensor. It's a sensor, but it's a switch. And if you look at it and look at the model number, it says switch. Okay. So I have the drawing here, 24 volts DC. Oh, check this out. 24 volts DC. This is the same page. 24 volts DC, 120 single phase, 208 control. Pay attention with your meter. If you don't know how to read wiring diagrams, take the selector switch and put it on auto detect so you don't blow your meter up, and it will automatically switch AC to DC for you. But don't be that dude. Be the dude that knows. So here we go. Oil switch. This is good, that means I'm running. But now I need oil. I'm going to close that switch 1 to 3, passing 24 volts DC to this coil. So the first thing I would start, where does the circuit start? It starts with the sensor of the switch. So that's where I'll start, because we're doing the order of operation first. And then what is that going to do? That's going to energize this low temperature compressor oil relay. How do I know? It tells me it's L2 LOR1. I have to read the language. And so that's going to simply close this normally open set of contacts. This is a dry closure. There's no voltage, as you can see here. It simply goes to a digital input board on my controller. So all I've done so far is told the controller, which one? I don't care. RDM, Copeland, Danfoss, Microthermo. It doesn't matter. It's a digital closure. So then I just told the controller, dude, I need oil. The controller says, all right, well, how about this oil valve control? All right, that's pretty simple. I close that board and point. When I close that board and point, it energizes LTOVR1. When that energizes, well, we already determined there has to be a coil or a relay pin somewhere, a normally open or normally closed set of contacts somewhere. And so let's start looking for L2VOR1. Here we go. Pin 6. Close that. Oh my God, can't believe it. We finally turned the solenoid on to energize the oil. Any break in this circuit was going to cause an oil failure, a mechanical issue. My compressor's off on oil. Why? All right, so now let's say I'm coming into here and all I know is my compressor's off on oil. Where am I going to start? I'm not going to start at the switch necessarily. I'm going to start at the solenoid, because that's what's not coming on to feed oil. So me personally, what I do is I'm going to, again, put my meter on T2 or L2, and and even on DC, I put it on the negative part of the DC. That's a negative voltage. It's not going to be like a neutral or whatever. And so I'm going to go on the other side. It's going back to source, AC or DC, AC and DC, greatest rock and roll band ever. Sorry. But I'm going to go, okay, he's not energized. Why? Where did I open the circuit? Well, being lazy, I'm going to go up here. The relay point, the board is right here in front of me. The electrical panel, it's right there. So I'm going to pop my meter right here. If I have, this is 208, I'm on T2. If I have 208 here, which way do I go? I know the controller said go. I know the controller closed the relay. I'm going this way. If I don't, do I have a bad relay? Is the fuse bad? Because I check voltage here. It could be the fuse on the relay output board, right? And that's how I would find it. Because I have voltage here, no voltage here. No, I have two questions. Is the controller calling for it? Remember, is the controller calling for it? That's something we get all caught up with, and we're going to cover that in a minute. Listen to what the controller tells me. Is it calling? Yes or no? Right? Is it calling? If it is, that should be closed. I probably have a bad fuse. If it's not, then I'm coming down here to see if I got a digital closure. Is he energized? Because if the controller's not doing what he's doing, maybe I'll check and see. I'd ohm across that to see if I had a closure. If not, I may check right here because the HB sensor simply did not switch from pins 1 to 2 to 1 to 3 and didn't send that 24 volts DC out to energize the coil. So does that make sense to everybody? You just have to think what's supposed to turn on, who's turning it on, and what voltage do I expect to see? Okay. And so when we get there, this looks complicated. And this is something I do. I carry colored pencils with me, learned it from the Army. I take and like if I get something from an OEM, the first thing I do is take out my electrical drawing and I color in my circuits, my black and red wires, so that I can see it quickly in my mind's eye. And I'm a big person. I think Trevor is too. I'm all about visualization. And so visualize your circuit and think about your circuit, and it's going to be easier. I'm telling you. You practice this method, and it's going to get you out of there a lot quicker. And it's going to stop you from going, well, on this switch, it's reading good now, and on this switch, stop it. Read the drawing, read the circuit in front of you. And I don't mean to make fun because I do that occasionally too. We really should be reading it here and doing it here.